Okay guys, this is going to be the AP Stats, the 9.1 and 9.3, kind of a review here of the quiz we took in class. I wasn't able to get the actual quiz into this Smart document for whatever reason, so I'm just going to kind of write things out. But there were two versions, both were really, really similar. So basically number one was talking about a lumber company trying to reduce the amount of cracks in the boards. And they want to see if they can, with a new method, reduce the number of cracks. So basically, part A was to state the parameter and then the two statements. So the statements would be HO, they said something about that the proportion is known to be 16% originally. So this is going to be a proportions problem, so P equals 0.16. And the thought or the claim was, does this new method result in fewer cracks? Okay, so the alternative, which would have a less than, a greater than, or a not equal. In this case, they specified they want it to be fewer. So P is less than. And make sure we're going to define what are we talking about here. P is the true proportion of boards with a crack, or of cracked boards. Okay, so true proportion, I guess we don't need that S there. So that's what this test is about. It's not mu, because it's not means, this is about proportions, right? I saw that the 16% in there, so that was kind of a hint to me there. So we defined the parameter, okay, and we had our statements. Okay, then later or earlier in the problem, they said, you know, basically this problem was done without, you didn't have to do the whole process. They were kind of saying they did a sample and they got a p-hat of 0.11, and then the p-value for that was calculated to be 0.027. Okay, so some problems you have to do that, sometimes they'll just give it to you. This was like a 9-1 problem where it's more about vocab and interpretation. Okay, so that stuff was there. And part B was interpret the p-value. So basically, what does this mean? Okay, so what it means, again, and I'm going to draw a little picture to kind of think about it. Basically, the thought process here on all these significance tests is basically once you have your conditions met, which, for the normal and all that good stuff, you know, we want to assume that the null hypothesis is true. Okay, so they're saying basically we're going to assume that the true population proportion is 0.16. Okay, so that means that the mean of all the sampling values, the sampling distribution, its mean would be 0.16 as well. Okay, we got a sample value of 0.11. Okay, so we took a sample of however many, I don't even think they told you, and your sample value came out to be here. Okay, now the p-value is that area in the tail there. That value is 0.027, just 2.7% of the time. You will get a sample as extreme or more than what you got. So that's the interpretation. It's basically saying the probability of getting a sample at least as extreme as ours. And again, it's all based on assuming HO was true. So assuming the mean really was 0.16. Okay, and we could probably do a better job using context here, like be specific, you know, what's the probability of getting a sample of boards, you know, less than 11% cracked if the true mean is really 16% or whatnot. So just be safe, use context a little better. But that's kind of the gist of what a p-value is. Okay, now in part C, there was two different versions. They wanted you to say what conclusion would be made at the 0.01 level, and then separately what conclusion would be made at the 0.05 level, I want to say. So depending on which quiz you had, and the answers are different. Okay, and the thought process again is this: if our p-value, okay, so we got something that happens about 2.7% of the time. For a significance level of 0.01, our p-value is greater than that. Okay, but in the other case, 0.05, our p-value was less than that. So with that significance level, that alpha, it's basically like a borderline. It's telling you, you know, how small do you need in order to reject HO. Okay, so with the first case, If the p-value is 0.01, they're saying, you know, if your p-value is larger than that, then it's really not enough evidence to reject HO. So what we would say, the way we would word this, I would just kind of say, since p is greater than alpha, we fail to reject HO. Okay, it's basically saying, you know, the sample that we got, you know, even though it was only, you know, 2.7% chance of happening, it wasn't small enough to basically reject HO. So in that case, we are actually going to we're kind of going with HO, right? When you say you don't reject it, it means we couldn't really prove it wrong. Okay, so we kind of, you know, believe maybe it's true. We're never going to come out and say that we accept HO, but what we could say is there is not evidence that P is less than 16. There's not evidence for HA here, right? We're going with HO. So there is not evidence that the new method helps. Okay, or to be real nice and specific, there is not evidence that the new method reduces the proportion of cracks. Okay, because we couldn't prove that it's less than 16. Okay, now on the other version, if this was your alpha, our p-value was smaller than that. So in this case, we would reject HO. Okay, and we would say there is evidence that the new method reduces cracks. Okay, because if we reject HO, that means we're going then with this claim. Okay, so the new method would have worked there. Okay, so let's talk about the part D, explain using context again the types of error. Okay, so basically here, type 1 error, if we remember this, you know, the two types, the little memory device was a routine for fun. Okay, and with type 1, we're using the beginning here, reject, true, null. Okay. Okay, so just remembering that memory device can help you do that, but then we still need to interpret it. You know, what does it mean? Be specific here. So go back to the specifics of the problem. The null hypothesis said that the proportion is 16%. Okay, we're rejecting that, but later find out that it's true. Okay, so if we reject it, we would be going with HA. So our conclusion would be, we would conclude that P is less than 0.16, that was HA, right, is true when it really is not. Okay, so we basically concluded that the new method helps reduce the proportion of cracks. So go back to, you know, this is when I say use context, I'm saying I would mention this again. That's kind of what HA said, right? So make sure you're wording that in there. I'm not going to write the whole thing again, but you have to go back to some sort of context to the problem. You cannot just say reject true null. That won't get you full credit. Be specific. Okay, we were basically concluding that the new method reduces the proportion of cracks, but maybe later we find out that it did not. Okay, type 2, just to completion here would be fail to reject a false null. Okay, and you could reason that out the same. You could fail to reject the null. You could say there is no evidence that that the new method works, but really later find out that there was. Okay, so always go back to the context. All right, number 2, again, both versions were fairly similar here. It's dealing with the mean weight of corn. So the first thing I would do is check conditions. So this one, I know they told us we had a random sample. That was right in the wording of the problem. So that was good. The normal, okay, this one, there's a little bit of an issue. I know our sample size was only 28, so we didn't quite have the 30, but they were nice and they kind of told us there was no outliers. Okay, so what that is That's basically saying if you were to plot the sample values, there'd be no outliers. So that would kind of be good enough for us to use the normal. Remember, we said these procedures are a little bit robust. You don't have to be exactly 100% sure as long as there's no major outliers or major skewness. So we'd kind of be safe to do that. You might want to mention something. A lot of you guys brought that up. That was a good thing. And then the third one, of course, being independent. Most of the time you have to assume that because you don't know the population size. But we would assume that capital N is greater than or equal to 10N. Our N was 28. I would assume there's more than 10 times that number of ears of corn out there. So that one can be assumed. So those need to be mentioned. Okay. Then we're ready to write our statements on these. That's going to be our next step. Okay, and this one was talking about they believe the mean was 8 ounces. The question was, does this fertilizer have a positive impact? Do we have evidence of that? So meaning, are they larger? So basically, I would write my HO as that the mean equals 8. My alternative is that it's greater than 8. And again, defining that parameter, mu is the mean weight. Of the corn. Okay, so there's our statements, and we are ready to set up our model and see what happens. Okay, so we have, again, the normal condition was met. I always start out by putting whatever HO says the mean is, and now we look at what was given to us from our sample. Okay, so they told us a few things. They gave us a sample mean of 8.25. And this was one of those ones where we assumed we knew sigma of 0.8. Okay, so that's going to allow us to use normal. We don't have to use t. Okay, so basically what we do then is ask ourselves, how likely is it to get a sample like that, or farther away from the mean, or more extreme? So again, the 8.25 is up here. My p-value is going to be this area here. Okay, so it is going to be a normal CDF problem. Okay, and I'm looking, where did I shade? Okay, this is where there's a lot of mistakes. People want to put 8, but we started shading at 8.25. We are unbounded to the right, so big number. Our mean was 8. Okay, that's always from HO, right? And we can see it on our picture. And then the standard deviation, again, the 0.8 is for the population. Okay, for the model we drew, this is a sampling distribution. It's going to be 0.8 divided by root n, and that was 28. Okay, so make sure we watch that. It is not just this 0.8. That 0.8 is for an individual ear of corn. Okay, we're talking about the mean of 28 pieces of corn. Okay, the standard deviation is different. Remember, this is known as our standard error when you use the formula there. Okay, and just a note, the other version, the only difference was there was an 8.24 here instead of 8.25. But it does make a difference. You'll see in the answer. So with this version, I got 0.049. Okay, for version B, I got 0.056. Okay, so that was using the 8.24. And again, it made a difference. Okay, when we go to make our conclusion, okay, with alpha being 0.05, I mean, you can see if you're comparing 0.05 to this one, that's a different answer than when you compare 0.05 to this one. So even just being slightly different in your sample value can really change the whole conclusion of this. So that was kind of I put that in there for a reason. I was going to mention how, the significance level is just kind of like something you choose ahead of time, but it's not like a clear set in stone answer. Because let's make our conclusions. For the first version, when we got 0.049, that value is less than alpha. Okay, so we reject HO. Okay, and what that means is there's not evidence that the fertilizer worked, right? We're going with HO. So we're kind of going with this guy. We don't have evidence for HA. So the first one, there's no evidence that the fertilizer helped. Okay, so that was using the 8.25 value. Now if we use this one, in that case, P was actually a little bit bigger than alpha, and that's when we failed to reject HO. Okay, and I'm realizing I think I just said the first one backwards, didn't I? If we reject HO, sorry, I said the first one wrong. Let's go back to this one right here. If we reject HO, okay, that means we are actually going with this. Okay, so I'm sorry I said that. So make sure you double check that. There actually is evidence. When you reject HO, there is evidence that the mean is a bigger than 8. Okay, so sorry, I had those switched around. It's the other one. If you fail to reject HO, that's when that means we're going with this one. So that's the one with no evidence that the fertilizer helped. Okay, so once you make your decision, either rejecting or fail to reject, I always like to go back to the statements, and I just kind of rushed through that for a second, but go back to these and ask yourself, if you're rejecting HO, that means you're going with HA, so whatever that conclusion is, okay? So just be careful on those. Big things about using context. Again, we always want to make sure that whoever's reading or looking at your study or your results kind of knows specifically, because not everyone's going to know. If you're publishing a report or whatever and you say I reject HO and that's the end of it, chances are the reader's not going to know what that means. Okay, and maybe if you're in like class in a school setting, they will. But if someone's just reading an article, a study, they're going to want specific, context, meaning just kind of tell me what you think based on the actual problem. Okay, so keep focusing on that vocab, and that is 9.1 and part of 9.3.